In the last lecture, I presented some types of inference rules and categorized them as either inductive or deductive. For each type, there are many particular inference rules. Take, for example, generalization. One particular instance of a generalizing inference rule is whenever you have observed at least 9 objects of kind X to have property R, then conclude that all objects of that kind have property R. That's probably a pretty bad rule because 9 is quite a small number of observations. The inference rules that scientists actually use look a bit more complicated. One such rule is whenever the probability of observing R, given that H is true, this is the so-called p-value, is smaller than the significance level of 0.05, then reject H. Let's not get bogged down in the detail here. We'll discuss this later in the statistics lecture. What matters, rather, is that there are very many particular inference rules. In fact, there is a continuum of such rules. An alternative to our simple rule A is to insist on having made at least 10 observations, or 11, or 12, and so on. An alternative to the more sophisticated rule B is to use significance levels of 0.01 or 0.1, or in fact any other number between 0 and 1. Now recall what these rules are used for. They are used to justify inferences. For example, you might ask me, why do you believe that all objects of type X are red? And I might answer, I observed 9 objects being red, and by inference rule A, I am justified in believing that all X are red. Scientists, of course, don't use such simple rules like A, but they do use something akin to B, exactly for the purposes of justifying why they accept or reject certain hypotheses. But B is just one rule on a continuum of rules. So why would scientists use B instead of some of the infinitely many alternatives? In other words, how is the choice of an inference rule justified? Particular inference rules thus justify conclusions only if they themselves are justified. Be careful to distinguish these two issues. First, that inference rules justify conclusions, and second, that the choice of a particular inference rule itself must be justified. In the remainder of this lecture, I will focus on the justification of inference rules, in particular inductive inference rules. The justification of deductive inference rules is also sometimes discussed, notably by Lewis Carroll, when he wasn't dreaming up white rabbits. But I'll instead focus on the skeptical argument against induction by the Scottish philosopher David Hume. Hume published his so-called problem of induction in 1748, but it remains as fresh and unresolved as it was then. Let's therefore have a closer look at the structure of his argument. Hume starts by assuming that there are only 2 kinds of inference, inductive and deductive. He uses these categories in pretty much the same way as I presented them earlier, so there's nothing surprising here. In a second step, Hume assumes that to justify any inference rule I, such a rule itself must be inferred from some premise. Again, this seems pretty plausible, as it is often claimed that all justificatory arguments take on the form of inferences. Hume then assumes that such a justification of I cannot proceed deductively. That would require that the success of applying an inference rule in the future is simply an explication of that rule's success in the past. Or, as Hume himself puts it, just because an inference rule has yielded true conclusions in the past does not necessarily imply that it will yield true conclusions in the future. Again, this seems pretty plausible, as many of us have the experience of an inference rule that fails, even though it performed well in the past. From assumptions 1 and 3, Hume then concludes that the justification of I must proceed inductively. This is just a modus ponens conclusion, so no doubt here, but it is also pretty plausible as an intermediate result. Our only chance to argue that some inductive rule is a good one is by showing that it has worked well in the past sufficiently often so that we inductively infer that we can be quite confident, though of course never sure, that it will work well in the future. But now comes the decisive blow. If the justification of I must proceed inductively, then there must be a rule J according to which this inductive inference is performed. And then that rule J also requires a justification for which we could need another inference rule K and so on, leaving us with a never-ending quest for more justification. Philosophers call such a runaway chain an infinite regress. Ending in such an infinite regress demolishes any hope of obtaining a justification for what one wanted to justify. Hence, Hume concludes that no inductive inference rule can be justified. This is a very powerful argument, which seemingly demolishes our hope to justify inductive inferences. But doesn't science use inductive inferences all the time? Doesn't this then mean that scientists engage in practices that are not justified? In an earlier lecture, I had argued that being based on reasons was one of the hallmarks of science. In the light of Hume's argument, does this characteristic then disappear? Is science then irrational because it lacks justifying reasons? Please pause the video and write down your answer before continuing. Let's have a look at this claim about irrationality in science in more detail. Scientists make inductive inferences, so the first assumption. But by Hume's argument, any attempt to justify inductive inferences ends in an infinite regress. Thus, scientists employ unjustified methods and science is irrational. Quite an unsavory conclusion indeed. If we don't want to accept this, though, then we need to dispute either of the two premises here. One way is to deny that scientists need to employ inductive inferences altogether. That's exactly what the 20th century philosopher Karl Popper argued, and I'll come back to this later. Another way is to deny the impact of Hume's argument. As I said, Hume's argument itself has not been disproven. The infinite regress is there to stay. But perhaps one might find an interpretation of what justification means, which is not completely destroyed by such an infinite regress. So, what is the nature of justification? What is that which offers justification? Justification, as envisioned by Hume and others, seeks an ultimate foundation, a set of basic claims onto which all the other claims can be built or inferred from, in a similar way as buildings are erected. Although this is a powerful metaphor, it is also obvious that Hume's argument is very destructive here. If there is no proper foundation, if the ground continues to give, then one cannot erect a building, nor can one hope to justify anything. But the foundationalist view is not the only account of the nature of justification. An alternative is so-called coherentism. Its basic idea is that a claim is the more justified, the more it forms a coherent system with other beliefs one holds or claims one accepts. The Austrian philosopher Otto Neurath used the metaphor of the ship at sea for this view. Scientists are like sailors who, on the open sea, must reconstruct their ship to keep it afloat, but who are never able to return to dry dock to lay a new foundation. Coherentism might make the impact of Hume's argument less severe. Inductive inference rules might not be the foundations of inductive practices, rather they might serve as abstract descriptions of such practices, and they might serve as tools to connect such practices with each other, as well as with other more abstract arguments and intuitions. Then both the practices and these rules are justified if they cohere well with each other. And this holds both for different claims that one scientist holds, as well as for claims that different scientists make. We can thus deal with Hume's problem, but only by substantially changing our view of what justification is. Formulating inductive inference rules, as for example statistics does, isn't deeper or more fundamental than everyday science. Rather, it just helps increasing coherence between practices and rules, and thus contributes to the justification of both.